Imagine a make-believe city filled with make-believe citizens, maybe a make-believe mayor, make-believe teachers, make-believe firefighters. Imagine this make-believe city has make-believe public infrastructure, like make-believe roads, make-believe parks, make-believe electricity, a make-believe sewer system. Now imagine you're the make-believe citizen in charge of your make-believe city's make-believe sewer system. Your make-believe job is to prevent and fix make-believe problems in the make-believe pipes below the make-believe surface. Imagine there was recently a make-believe rainstorm in this make-believe city. Any make-believe rainwater that infiltrates your make-believe sanitary system is going to give you a big make-believe headache. You'd need some way to detect when make-believe things are not how they make-believe should be. Of course, you could probably imagine everything I just described happening in the real-life, non-make-believe world. And luckily, for the real-life people who have real-life jobs looking after real-life sewer systems, or any sort of system where water flows for that matter, Teledyne ISCO's LaserFlow technology makes those real-life headaches disappear. Do you know ISCO? Before we get into lasers and ultrasonic sensors, we should discuss why knowing the flow rate of water is necessary in the first place. Flow rate equals area times velocity. When we say area, we mean the cross-sectional area of the pipe or channel occupied by water or other flowing liquid. When we say velocity, that's how fast on average the water is moving. Knowing flow rate is useful for billing customers, locating sources of inflow and infiltration, like we imagined in our make-believe city, among other applications. The LaserFlow finds flow rate by measuring both area and velocity simultaneously, thanks to its innovative, one-of-a-kind design.
Hi, I'm Rick Dye, Business Development Manager for Teledyne ISCO. I've been with Teledyne ISCO now for 36 years. I work with large flowmeter projects and have responsibility for flowmeter sales worldwide. LaserFlow is the only non-contact area velocity device in the world that actually penetrates below the surface of the water. There are a lot of other devices out there, but typically they use a radar system that measures the surface velocity. This requires to have some surface ripple or turbulence in order for it to get a reflection. The laser can read extremely low or very slow flow, as well as very high velocity applications. So it's the only one in the world that does the subsurface velocity measurement.
In addition to its velocity reading laser, the LaserFlow uses a non-contact ultrasonic sensor that bounces a sound wave off the surface of the water to measure its depth. If you know the geometry of the pipe or channel you're working with, you can solve for area, completing the flow rate equation. Non-contact here means the LaserFlow is left out of the water, which gives it a unique advantage when it comes to maintenance, accuracy, and plain old convenience.
A typical area velocity system, area velocity is a level measurement and a velocity measurement. The old-fashioned way, if you will, was a sensor that was on a ring in a pipe. So it used either a pressure sensor or ultrasonic to measure water depth. It then used a continuous wave Doppler sensor to transmit out the nose of that sensor to calculate the velocity. We know the area, we know the velocity to calculate the flow. The unique thing about non-contact is that now, instead of having a sensor in that flow, which a lot of times will get covered with debris and won't work, so it requires people to go in, have to do maintenance, clean that sensor, and a lot of times recalibrate it. Non-contact, in the case of the laser, takes all of that out.
Another important benefit of the non-contact LaserFlow is improved accuracy. The LaserFlow can be used in many more applications than just pipes. Streams, rivers, even wastewater treatment plants can all be monitored using the LaserFlow. If you had to submerge your flow sensor in the water of, let's say, a stream, the sensor is going to obstruct at least some of the flowing water. But with the LaserFlow reading levels from above, the water is left as is, allowing for unobstructed, accurate results. But how do the folks at Teledyne ISCO test the LaserFlow to ensure its readings are in fact accurate? Once more, we must make believe we're inside a real-life sewer system.
My name is Keith Belt, and I've been here at ISCO for 40 years. And I'm an engineering technician. And this is the ISCO flow bench. We have a 12,000 gallon tank and two large 10 horsepower pumps and one half horsepower pump. The 310 ultrasonic I have a 330 bubbler installed, the 350 area velocity sensor, and then the 360 LaserFlow are some of the main products we've been testing right now. So we have a product that we're testing. Normally they're logging, say maybe once a minute, logging readings like level, velocity, flow rate. So these meters, the mag meters, are pretty accurate, and we're logging those readings also. And so then I'll take my point gauge measurements, and so then we've got measurements to compare between the product that we're testing and the reference meters.
Engineers can adjust the flow bench to meet the needs of various different testing conditions. They have access to all of these different pipes with diameters ranging anywhere from 4 inches to 24 inches. They use a special fixture to raise or lower the laser flow to make sure it works correctly from different heights. They can adjust 4 scissor jacks holding up the pipes in order to alter the slope of the flow bench. Because of its ability to fine-tune these different variables, Teledyne ISCO is better able to realistically simulate the conditions of its customers' applications.
Open channel flow is kind of difficult to measure. Like on the other side, we have what we call closed pipe flow through the mag meters. So the mag meters just work by converting the velocity of the water to a voltage, and it gives us a flow rate. Open channel is a little more tricky because of the nature of the water, you know, and the waves, and say if you got a sensor in the pipe, you're causing an obstruction, and so the water will kind of build up as it hits that mounting ring. I guess that's what I like about the LaserFlow, is it's a non-contact flow meter, so it doesn't have any contact with the water, and they tend to give a more accurate reading.
High flow, low flow, fast flow, slow flow. ISCO knows flow, and the amazing LaserFlow can read it all.
Well, one thing I think people are surprised is that how low a flow that laser can read. So we are finding more and more applications where they might do industrial pretreatment, where maybe there's very little bit of flow that leaves their facility until they batch dump things. In the old days, they used a flume or a primary device in order to capture that flow. The problem with that was that you had to have it rated to be able to handle the high flow, and that would overrange it or be too high or too large for the small flow. So the cool thing with laser, or the unique thing with laser, is you do not need a primary device. You just have an open channel. It can read down to a very, very small amount of flow. Our specification's a 1/2 inch at 0.5 feet per second. So nothing does quite what laser will do in those types of applications.
Let's go back to our make-believe city. After the last make-believe rainstorm, the make-believe professionals using the Teledyne ISCO LaserFlow in their make-believe open channel pipes were able to detect a make-believe leak in their make-believe waste lines and fix the make-believe problem before it got too out of make-believe hand. Alright, you get the point, and that was more than enough make-believe talk. It's getting harder and harder to make out what's make-believe and what's real life at this point. Make-believe city, real-life citizen. Make-believe sewer system, real-life LaserFlow. Make-believe sewer system, real-life LaserFlow. That sounds familiar. Hey there, and thank you for watching this episode of Do You Know ISCO? Big thanks to Rick Dye and Keith Belt over here at Teledyne ISCO for helping with this project. If you want to see more about the LaserFlow, click the link in the description, as well as this video right here. For more Do You Know ISCO content, subscribe to our YouTube channel, follow us on our other social media channels, leave a like, and let us know what you think about ISCO. Thanks for watching.